All right, let's start with our carbohydrates. You're going to go find your glucose models, and you should have quite a handful of them. We're going to start with taking one of these glucose molecules and just mounting it straight away onto our structure page. Some of your glucose molecules will look exactly like this. Some of them might have the OHs in a slightly different position, but they're all glucoses. So we want to make certain that we've got documented down here one of our monosaccharides made by plants during photosynthesis. It's also used by organisms for cellular respiration. So we capture, well, we don't, but photosynthesizers capture the sun's light in the chemical bonds, the high energy chemical bonds between carbon-carbons and carbon-hydrogens, and they make this glucose molecule. Then the organisms who made this glucose in turn send it to their mitochondria, and they use it to make energy, which is ATP. For you and I, we have to actually go eat the plants or eat the animals that ate the plants to access this glucose molecule. Then we can actually send it into our mitochondria to make ATP through cellular respiration as well. So this is our most important molecule of all the biomols. So the next thing you're going to do is we're going to try and make a polymer. We're going to grab a couple of these pieces and we're going to lay them out next to each other. And we've got to actually find how we can connect them. And when you look closely at them, and you've seen this on your CK12 work, when you look closely at these two monomers, you can actually see where this small molecule and this molecule can attach to each other and release a water. You can actually see a little bit of a cut there. This is a carbon with a bond to the oxygen, another bond to an oxygen, another bond to a carbon, and then a bond to a hydrogen. And then over here we also have a carbon with 1, 2, 3, and 4 bonds. So they're all happy. So we've got to pull from our hydroxides. We're going to yank some of our atoms off of these two OHs. So to do that, we're going to snip off a full OH on one of these and then just an H from the other. And so what you'll find is when you pull those two, let's just do one at a time. When you pull those two molecules, you'll actually see that you can pull off. On my molecule, I had an OH coming down, so I pulled the whole OH off. There it is. And then over on this side, I took one of the H's off this hydroxide. So I pulled one H from this side. There it is. And on this side, I pulled the OH off. So very carefully with your scissors, you're going to surgically cut them away. When you do, you then formed a molecule of water, and you can see it drip away. And then you're going to make a new bond. Wherever you took the OH off, that carbon is now missing a bond that used to be holding on to oxygen. So we're going to reach across. Wherever you took the H off, that oxygen is missing a bond. So this carbon can now hold on to this oxygen, which is quite a strong bond. And we're going to highlight that, and then we're going to glue it all down. Your goal is to try and see if you can make a polymer. And I've done one here for you. Again, yours might look a little bit different than mine because your glucose molecules might be in a little different order. However, I can see I pulled a H off of this one and an OH off of this one and made my water molecule. My next one, I pulled the whole OH off the top, and over here I pulled the H off the side. So there's my water molecule. And then my last one, so a polysaccharide is going to be more than 3, many. Usually we'll have hundreds or thousands. But this last one, I pulled the hydrogen off of this oxygen, and off this carbon I pulled all the O and the H. So I've got another water molecule. And then at the end of this, I'd like to make certain that we are documenting this properly. And down at the bottom, you've got that this is a polysaccharide, and usually there are hundreds, if not thousands, of monosaccharides joined together.